Welcome guys. Now today we'll be looking at power. If we can just go back, we've talked about work done, and we said work is only done if now there is a force acting on an object. And let's say this object is moving on a rough surface. Now there's a force acting, and this force can displace an object. So it means the object maybe has been displaced by that much. And let's say this is your delta x. For sure, if the surface is rough, there will be frictional force acting in the opposite direction. Then here we're saying when a force acts on an object and the force displaces an object, then we talk about work done, which can be represented by work done equals to force acting on an object and causing the object to move. So which is like your work done. If we can just for now ignore the direction, saying that it just move in one direction, we're considering the force applied. So then if we can just make one change in this system, remember you have this object. Let's say this object is having the mass small letter m, m. It is too much pressure. There's so much pressure. Okay, then if you make few changes in this system, let's say now on top of this object you stack another object. Let's just copy and paste so that we can show that. Now if you decide to put another object on top of this object, all right, then definitely if we say okay, let us keep displacement the same. So what we are going to keep the same here is delta x kept the same, and we keep the force applied the same. Definitely you would agree with me that if you add another force here, so another object here, frictional force is going to be affected because of the fact that Fk is equal to mu k normal force. So whereas normal force is equal to weight, so once you add another object on top of this object, so the mass increases. So if the mass increases while g remains constant, it means weight increases. If weight increases, it means normal force increases. Now if you check here, if the normal force increases, it means kinetic friction also increases. So it would mean here now your friction gets affected. I'll just use red. Your friction increases. Now then once the friction increases, it would affect the net force, because now the force opposing motion has just gone up. So the forces now, the net force would therefore be less. If the net force becomes less, it means the object won't be as fast as it was before. So for instance, if you check here now, then your delta T compared to delta T to take the same displacement or to cover the same displacement, it will not be as fast. So it means here your delta T would be decreasing from Phanga Center. So this now understanding of trying to check how this time affects now this system, it brings us to something which will be known as power. Now power has to do with energy transferred, because as I said, work is done, and when work is done, it means there is a transfer of energy. Now for instance, in this case, this object gains energy. So I mean the energy is transferred to, because it is able to move from here to that position. So if this force acts on an object, it gives this object an energy, whereas the friction takes the energy out. So in this second case now, the energy taken out has increased while the energy put in remains the same. So it would mean then the object must be slower, must be moving at a slower pace. Then, now if we bring in this power now, power, we're going to say it is equal to, all right, I think I can just write where I have enough space, no need, all right, just drag it, oh, sorry, drag, okay, like that. Now, power, will define this power, or will give this power a formula, so that we come with the definition later. We'll give it a formula saying that now this power will be energy transfer divided by time taken to transfer such energy. All right, so in symbols it means we have P is equal to, remember we have said work done, which is like W, is same as energy transfer. So it means here we have W over delta T, that is your change in time. All right, remember work done is a scalar. I think we've agreed with that, or on that. And SAT, it has units as in joules because it is energy. Then time will be a scalar again, measured in seconds. So in other words, it means our units here will be joules per second or watts.